This video begins the Math 3 exam review material from Test 3. And problem number 30 says, simplify the expression, write the result using positive exponents only. So you'll notice this is a multiplication problem, so we will multiply the coefficients to get negative 14. And when you're multiplying like bases, remember that you're adding the exponents. So x to the negative 4 times x to the 3, you add negative 4 plus 3, gives you x to the negative 1. Let's do the same thing with the y's. Y to the third times y to the first, add the exponents, 3 plus 1 gives you y to the fourth. Remember that we want positive exponents only. Well, the x violates that rule. We can leave the negative coefficient, that's not a problem. And this y value has a positive exponent, but this x variable does not. So remember that we're going to move that from the numerator down to the denominator, and this is going to become negative 14y to the fourth. That remains in the numerator. Bring down the x to the negative 1, it becomes x to the positive 1 when you move it down, and you'll see that it's just x. So this is the answer to that multiplication using positive exponents only. Now for number 32, there's more than one way to do this problem. We'll just start, my way is what I'll use this time, but there's more than one way, and your way it could be just as valid. What I'm going to do is raise each exponent, each term here, to that power. So 4 to the negative 2, a to the negative 2, b to the fourth to the negative 2. Recall we're doing power to a power, so you multiply the exponents. So I'm going to get 4 to the negative 2, a to the negative 2, b to the negative 8. That's the numerator multiplied. Okay, 5 to the negative 2, a to the positive 6, because negative 3 times negative 2 is positive 6, and b is to the negative 4. Okay, well, this certainly violates the positive exponents only rule, so we've got to move everything except this a to the sixth. So all of this in the numerator will move down. All of this is going to move down, and everything except the a to the sixth, that's going to move up, and that's going to move up. So after the move, without simplifying, this is what it's going to look like. 5 to the second, b to the fourth. That's not up there anymore, sorry. Okay. And in the denominator, we have the a to the sixth, and then everything from the numerator came down. So that's 4 to the second, a to the second, b to the eighth. Okay, so now just clean all this stuff up. So 5 to the second is 25, b to the fourth, and in the denominator here we'll put the coefficient first, so 4 to the second is 16. A to the second and a to the sixth, they're being multiplied, so we add the exponents, a to the eighth, b to the eighth. Well, it's almost simplified. We cannot have two occurrences of the same variable in the problem. It's not simplified unless you have just one occurrence of a variable. And you need to make sure that the 25 over 16 doesn't simplify. Well, it doesn't, so we're going to leave the 25 over 16. And the a to the eighth is going to stay where it is. But remember the b to the fourth and b to the eighth, you subtract the exponents, so 8 minus 4 is 4. And we would put the remaining b to the fourth in the denominator because the 8's larger than the 4. So that would be b to the fourth. And there's the answer. And of course, now we have all positive exponents. Number 32 says, perform the operation and simplify. The operation here is subtraction. Okay, so we want to subtract. That means bring down the first polynomial with no changes. I'm just taking off the parenthesis. The subtraction means to distribute the negative. So negative times a negative, that's going to be positive 6x squared. Negative times a negative is positive 8x. Negative times a positive is a negative 9. And now I'm just going to collect like terms starting with my highest exponent. So my highest exponent is 6x squared, and I do not have any other x squared terms, so I'm just going to bring that down. And I'll just draw a line through that so I know I've used that term. My next term would be x to the first, and I have 16x plus 8x, which gives 24x when you combine them. And I'll get rid of those. And then the constants, plus 9 minus 9, well, they just cancel. And this is your answer. Okay, for problem number 3, again, perform the operation and simplify. Notice there is no operation between the two parentheses like in number 32, so this is a multiplication problem. And it's a binomial times a binomial, and with that we use the technique called FOIL, first, outer, inner, last. So I'm going to multiply the first two terms together. 3y times 2y is 6y squared. I'm going to multiply the outer two terms together. 3y times negative 1 is negative 3y. I'm going to multiply the inner two terms together. 7 times 2y is plus 14y. And I'm going to multiply the last two terms together. 7 times negative 1 is negative 7. And after you FOILed, you see how happy you are. It makes a little happy face. Okay, and now what we want to do is collect the like terms, which in this case are the two middle terms. So you get plus 11y minus 7. And that is the answer. Okay, with problem number 34, you can use the special rule, or remember you can always write this twice and use the technique we used in problem number 33, which is to FOIL it. But we're going to use the special rule here. So remember the special rule: when you have a binomial squared, you square the first term, so that's going to be 4a squared. You multiply the two terms together, so 2a times negative 3 is negative 6a, and double it. That means multiply it by negative 2, well, by 2, I'm not negative 2, so that's negative 12a, and then square the last term, plus 9. Okay, so square the first, multiply the two terms together and double it, square the last. And that's following the rule, but of course you can still get the same answer by simply FOILing it out. Okay, number 35, you have a binomial times a trinomial, where you certainly can't use FOIL for this. What we have to do is multiply the first times everything, and then multiply the second times everything. And then we'll collect like terms. So z times z squared, and so forth. And then negative 5 times the whole term. Okay, so you've done all the multiplications. You've distributed the z and distributed the negative 5. Now collect your like terms starting with your highest exponent. So z cubed. We have two of z squared terms, and one is positive 5, one is negative 5, so those cancel. We have two z terms, negative 3 and negative 25, which gives you negative 28z. And you have one constant term, just bring it down. So here's the answer.